Hey everyone, welcome back to the channel. In my previous lecture, I gave you a proper description about JVM, JRE and JDK, how they work together. Now, in this lecture, I am going to teach you the 4 core fundamentals of any object-oriented programming language. Whether you are a beginner or you want to secure a good mark in your university or college examination, or you are brushing up for your interviews, this is the perfect place for you to master Java in an efficient way. So let's dive into it. Object-oriented programming language. What we are going to learn in this session? We are going to learn what is abstraction, encapsulation, inheritance and polymorphism along with their implementation, and we will also see the real-life examples of them. First, introduction to object-oriented programming in Java. Java is a fully object-oriented programming language. What does this mean? Everything in Java is just a classes and object based on 4 fundamental principles. First, encapsulation. Second, inheritance. Third, polymorphism. Fourth, abstraction. Encapsulation means restricting the outer access. Inheritance means getting all the characteristics of the superclass. Polymorphism means one method, many interface. Abstraction means hiding the implementation details. These principles allow modular, reusable and scalable code development. 3 fancy words: modular, reusable and scalable. Looks so much good, but what does they mean? When you will become a programmer, you will write your own code by using packages, by using classes, interfaces to make your own project, combining them all together to make your own project. That is called modular. Reusable: whatever code you are writing, that can be reused by any part of the program. Scalable: suppose that right now your application or software is running 3 users per day. In the future, it can happen that your application or software is running on 3000 users per day, and you have to write the code in an efficient way that it can handle multiple users without crashing. Abstraction in Java. Abstraction is an object-oriented programming principle that hides the implementation details and only exposes essential features to the user. What does this mean? Suppose that right now you want to eat a burger or pizza from the nearby restaurant. You have to go there by your car. You start the car, push the accelerator, turn the wheel to change the direction. You reach the destination. Now, do you know how they work together? Do you know how the wheel work? Do you know how the accelerator work? You don't know. That is because the manufacturer wants to hide the implementation details from the end user. You just know what they do. You don't know how they do it. That is called abstraction. It allows developers to focus on an object does rather how it does it. As I have told you, it focuses what rather than how. A powerful way to manage the abstraction is through the use of hierarchical classification. Hierarchical abstraction is a method of organizing complex systems or information by breaking them down into progressively simpler and more manageable levels or layers. Examples of that: computer programming. Object-oriented programming with its use of classes and inheritance is a prime example of hierarchical abstraction. What is this hierarchical? It means that everything is organized in a way that the superclass will be in the top, the subclasses will be in at the below of that superclass, line by line. Suppose that what is hierarchy? First of all, understand that. Suppose that your father has some properties. You have some common properties with your father. Your father is the superclass or parent class. You are the child class. Now you will have children. He will have that feature, or you can say characteristics of you and your father. That is called hierarchical abstraction. System design. Hierarchical abstraction is used in designing complex systems such as operating system, databases, communication networks. Human reasoning. Humans naturally use hierarchical abstraction to organize their knowledge and solve problems. Key features of abstraction: hide complexity. User interact with a simplified version of an object. Many real-life problem is complex, and when solving them, you need to write complex programs, and you don't want to show those complexity to the end user. That's why you hide the complexity. That is called abstraction. Improves code maintainability. Changes in implementation do not affect the external code. Enhances security. Prevents direct access to the implementation details. How abstraction is achieved in Java. Abstraction in Java achieved by using 2 keywords: abstract and interface. How? Look at this. Abstract, interface. In our future lecture, when we will have the basic ideas of Java, we will teach you briefly what is this abstraction and how it is achieved. Right now, it is enough for you. Encapsulation, data hiding. What is encapsulation? Encapsulation is binding of data and methods into a single unit, a class. It restricts direct access to data members and allows control access through getter and setter method. This ensures data security and integrity by preventing unauthorized modifications. Suppose that you have a private diary, you write many things there, you don't want anyone should read that diary. That is called encapsulation, restricting other from using the data. And if encapsulation is not properly implemented, many loss can happen. You know that the cyber attacks that happens on software applications, it happens because of lower level of encapsulation. Data hiding. Instance variables are declared private, meaning they cannot be accessed directly from outside the class. Control access. Public getter setter methods provide access to the data safely. Improved code maintainability. Implementation details can be changed without affecting the outside code of encapsulation. Look at this example of encapsulation. Here you can see a keyword called private. It restricts this balance variable to be accessed by outside of this account class. Suppose that you want to access that from this bank class, it cannot be accessed. But if you want to access this balance from inside of anything, any member inside that class, that can be accessed. That is called encapsulation. Inheritance. What is inheritance? Inheritance is the process where a new class acquires properties and behaviors of an existing class parent. As I have told you, you have many characteristics similar to your father. That is called inheritance. It promotes code reusability and hierarchy based organization. The parent class is called the superclass and the child class is called the subclass. Your father is the parent class or superclass and you are the subclass. Types of inheritance in Java. Single inheritance. One child inherits from on parents. You inherit characteristic from your father, that is single inheritance. Multi-level inheritance. A child inherits from another child class. You have many properties or characteristics similar to your brother, that is called multi-level inheritance. Hierarchical inheritance. Multiple child classes inherit from a single parent. You and your brother inherits many things from your father and mother, that is called hierarchical inheritance. Multiple inheritance is not supported by Java. Advantages of inheritance. Code reusability, avoids redundancy and repetition, improves code structure, creates a hierarchical classification, easy maintenance, enhancement in the parent class automatically, reflect in the child class. Avoid redundancy and repetition. Suppose that you are, all of you have played the game like Free Fire, Clash of Clans, PUBG, BGMI, whatever you called. In those games, there are many characters, but they have similar characters. There are many characters, but all of them have some similar characteristics like running, jumping. And suppose that you are creating the game. You created a class called human or character. Inside that you have two methods. One method for jumping, one method for running. Now you want to create individual character with the characteristic of running and jumping. You don't need to write the code for that because you have a super class called character or human. You just inherit all the characteristics from that super class and you write the own characteristic of that character. I believe that everybody has played Free Fire, BGMI and PUBG, whatever you call. In those games, there are many characters who performs many tasks, but the common features or characteristics of those characters is that they can run, they can jump. Right now, you are the game developer, you want to create the game and you have a task to create the character. You have created a super class called human or character that has two methods, one for jumping and one for running. Now, you want to create a character which has some extra feature like powerful boxing or anything. You can implement this by inheritance. You can inherit all the properties of that superclass called character or human that can run or jump. Now, in your class, suppose that your class name is Boomba. In that Boomba class, you inherit all the properties of human or character class. Now, it has those two properties and you will create your own method inside this Boomba class for powerful boxing. This is how inheritance is achieved. Creates a hierarchical classification, improved code structure. Because you don't need to write so much of code, it is easy for other developers or even for you to improve the code for further. Easy maintenance, as it is maintainable because the code is not redundant. That's why it is easy maintainable. Example of inheritance in Java. Look, here is the vehicle parent class. A vehicle can be car, scooty, motorbike, truck, anything that has a common feature called honk. And there is a car class which will inherit, and there is a car class which will inherit all the properties of vehicle. This is how inheritance is achieved in Java. Polymorphism. Polymorphism is a Greek word which means many forms that allows one interface to be used for general class of actions. The method of execution is determined at compile time or runtime. Consider a function for a square which returns the square of a number. Now, you can create the square method for two times with the same name, but one for integer value, one for floating point value. By using polymorphism, you can write a class like this, compile time polymorphism. Look at this example. You have created a class called square. Inside that square class, you have two methods with same name, square, but one for integer, one for floating point value. Both of them are returning the square value of the parameter. Now, suppose that you want to get the square value of 10 and 10.5. The data type of them are different, but you can use the same method name with different data types to get the square value. It cannot be done in C like this. You have to create different method for different data types. Types of polymorphism in Java. First, method overloading. Same method name with different parameters. In the preceding example, same method name but different data types. Second, method overriding. Same method name with different implementations in child classes. Runtime polymorphism. Look at this, runtime polymorphism. First of all, you have created animal class which have a method called makeSound and child class. Child class of that is class dog extends animal. Look at this. You are overriding this method here. That is called runtime polymorphism. Look at the method name, they are similar, and this is called polymorphism because it has the same name of method but different interfaces. Polymorphism, encapsulation and inheritance work together. When properly applied, polymorphism, encapsulation and inheritance combine to produce a programming environment that supports the development of far more robust and scalable program that does the process oriented program. When you will create real life problem that is complex, you will use polymorphism, encapsulation and inheritance together. Look at this table. First of all, abstraction. What it does, it hides the implementation details and so essentials only. Achieved by abstract and interface. Encapsulation, what it does, it binds data and hide it. And how it is achieved? By using private and getter setters. Inheritance, reuse of code from parent class by using extend keywords. Polymorphism, on interface many forms. And how it is achieved? Overloading, or you can say compile time polymorphism, overriding, or you can say runtime polymorphism. Thank you so much for being with us. If you like this lecture, please hit the subscribe button, give us a like and comment below if you have any problem. Have a good day.